Today is December 15th, 2011. We're on lesson 7.3. Now, the last 2 days we've been working with these formulas, the amount of a regular annuity and the present value of an annuity. Okay? We're going to use these two formulas again today, but we're going to solve for variables in the formula. Before we were just solving for A, which was our annuity, and the present value. We're going to look for regular payments today as one of our formulas. Okay, so what we're going to do is the first example out of your textbook, which is on page 428. The question says, Brienne wants to save $6,000 for a trip she plans to take in 5 years. What regular deposits should she make at the end of every month or every 6 months in an account that earns 6% compounded semi-annually? So a lot of things were said in this question again. Brienne wants to save $6,000, so that's our annuity itself. The total amount, our A, is the $6,000 she wants to have at the end of everything. She plans to take a trip in 5 years, so that means the years in this question is going to be 5. We're talking about 5 years' time that she needs to have $6,000. What regular deposits should she make at the end of every 6 months in an account that earns 6% compounded semi-annually? So we got to figure out our interest rate. That's our R in this question. They've told us the interest rate is 6%, which as a decimal is 0.06. And the compounding period, in this question was semi-annually. So what does that mean in terms of C? Semi-annually. Anyone know what that means? Twice. Every 6 months that means, okay? So that means every 6 months, twice a year, semi. So we have our A, Y, R, C, and R. But in terms of our formula, okay, the variables are, this is an annuity. We have the A value. We also don't have yet our I value, lowercase I, and our N value. So we have to solve for these two. Which means we got to put them into this formula here. So in order to solve for our N in the formula, we need to plug in our years times the compounding periods. Okay? So what that means for this question, N is equal to, our years was 5, and our compounding periods was 2. So N, if you look at the definition, is the number of compounding periods. There's going to be 10 compounding periods. They're going to earn interest 10 times over the course of 5 years. That's what our N is telling us. For our I is the interest rate earned each compounding period. So I is equal to our R, which is 0.06, divided by our compounding periods. So in this case, I is going to equal 0.03. So what that says is every 6 months, the money earns 3% interest, okay? It's compounded semi-annually. So over the course of a year, it's a 6% interest. The faster things compound, technically, the more money you make, as you guys would know from the questions you've been doing for homework. So we have all of our variables. We're going to plug them into our formula for an annuity. We're going to take our formula here. And we're going to plug our values in. We have A, which is 6,000. We know that Brienne needs $6,000 at the end of the period of 5 years. We're going to need to calculate the regular payments. The formula, 1 plus our I, which in this case is 0.03. It's going to be to the power of 10 because there are 10 compounding periods over the course of 5 years when we're getting money semi-annually. So we're to the power of 10. Subtract 1 and brackets. And this is all divided by, again, the interest rate. And the interest rate we saw before was 0.03. So now we've plugged these all in. Our goal is to figure out what the regular payments need to be in order to have $6,000 at the end of 5 years. Okay? So we need to rearrange this equation just like we were doing in the last chapter. The very first thing I'm going to do, this entire right side of the equation is divided by 0.03. So I'm going to move that over first. In order to move it over, what do I have to do? Multiply, that's right, because this is a division sign here. So the left side of the equation will read 0.03 times, I'm going to write the rest in black now, 6,000 is equal to our regular payments multiplied by, now I'm going to simplify this a little here, 1.03 when we add it together to the power of 10 minus 1. Okay, so we're going to calculate that number on the side, 6,000 times 0.03, 180. So we get 180 is equal to R. And now in these brackets, I'm going to equate 1.03 to the power of 10. So 1.03 to the power of 10. Equate the number there. Who can read that to me? So that's 1.03 to the power of 10. We still have to subtract that number by 1. We're going to get 180 is equal to our R. 1.3439, subtract 1, it's just going to be our decimal, 0.3439. The 1 goes away. And now in order to isolate this R, what do I have to do? What do I have to move here? Yeah, and in order to do that, what do I have to do? Close. Divide. This says multiplied by. R times this. So in order to move it to the other side of the equation, we need to divide both sides of the equation by this much. Okay? So on the right side of the equation, they're going to cancel out, and we're left with just R. R is equal to 180 divided by that. So 180 divided by 0.3439 and 523.38. All right, 523. Oh, 0.4, round it up. All right, 0.40. So what they just told us here was, Brienne, in order to have $6,000 after 5 years, she needs to invest every 6 months $523.40. Okay? We're going to take this a little farther. That's the amount she's putting in every 6 months, and she's doing it for 5 years. So if she does this every 6 months for 5 years, how many times does she put that amount of money into the bank? 10. That's right. Exactly what our N is. So what we're going to do next is we're going to calculate how much money she's actually investing, which will help us figure out how much interest she's earned. So our next page here. Okay. We knew that our N was equal to 10. There were 10 compounding periods, and her regular payments were $523.40. Okay. So to figure out the total amount, what do I have to do with these two numbers? Multiply. If I multiply these two numbers, we'll figure out the total amount. I'm going to do this really quickly. The total invested by her is $523.40 times 10, which will be $5,234. Okay. So she's invested $5,234. How much did she have at the end of 10 months? We figured out in the last part of the question. $6,000. So $6,000 is how much she actually has because she was earning interest. How do we figure out how much interest was earned? I'm going to subtract these two numbers. So I'm going to bring this down, and we're going to subtract these numbers. 2, 3, 4. Subtract them. 9, 9, 5. 6, 6, 7. There we go. So Brianne earned in the 5 years $766 in interest by investing $523.40 every 6 months at 6% compounded semi-annually. A lot happened there. Okay, example number 2 says Donald borrows $1,200 from an electronics store to buy a computer. So he's buying that he's borrowing that money right now. He will repay the loan in equal monthly payments over 3 years. Starting 1 month from now, he's charged interest at 12.5% per year, compounded monthly. Holy smokes, this guy's getting ripped off. How much is Donald's monthly payments? So we got to make sense of all this. He's borrowing that money right now. So are we talking about using an annuity, so the future value of something, or the present value of something? Present. So we're using our present value formula because he's borrowing this money right now. It's very important we start to distinguish between the two formulas because they are quite different. Okay. So the present amount that Donald borrows is $1,200 to purchase a computer. It says he's going to repay the loan in monthly payments over 3 years. So our years for this question, 3 years. That's how long it's going to take him to repay this loan. He's going to get charged 12.5% a year. So remember, that's our interest per year. So that's going to be 12.5% or 0.125 as a decimal. And remember, this is per year. Okay? And it says he's getting compounded monthly, his interest rates. Very unfortunate for Donald here. So, monthly. Compound, what does our C equal if we're talking about being compounded monthly? How many months occur in a year? 12. So our C is 12 in this question. Okay? Now again, let's take a look. We figured out what our PV is here, but I need my I and my N. So I actually have to solve for those two again, just like we're going to have to do each question. So we need to use our N formula and the I formula in this question to solve. So our N is going to be multiplying the amount of years by the compound periods. That's right. So N is equal to our years, which is 3, multiplied by the compound periods, which is 12. So he's going to be charged interest over the 3 years 36 times. Okay? Every month for 3 years, he gets charged interest on his loan. So 36 times he gets charged interest. The interest rate, each time he gets charged, so that's our I. Our I is equal to 0.125 divided by 12. Okay? So what this is our I is telling us that he gets charged 12.5% over the course of the year. But because he's getting it split into 12 different sections, he gets charged a 12th of the interest rate, which we're going to calculate as a decimal. So 0.125 divided by 12. Oh gosh. What does that read? Anyone know? What was it? 0.0104. That's good. Okay? So it looks like 1.04% interest every month. Okay? So now we figured out our I and our N. We're going to put this into our formula to solve for the regular payments. Because he wants to pay it off at the course of 3 years. This is similar to calculating mortgages. This is a loan here, okay? This is something that's very applicable to you guys. Say this was a student loan, and you're taking out a student loan for college. This is the exact kind of formula you need to calculate if you want to pay it off by a certain deadline. This will tell you what you got to invest every single month in order to pay it off, say, in 2 years, 5 years, 10 years. The formula changes depending on the length of time you want the loan for. So we're going to plug it into our formula. We remember that he had a loan of $1,200, and we're using our present value formula. Regular payments multiplied by 1, subtract 1 plus our I here, which is 0.01. Our I is 0.0104. Okay. And he's being compounded over the course of 3 years every month, which means 36 times he's charged interest. Okay. It's a high interest rate, but monthly compound periods are very common. Very common for student loans, very common for any type of loan you're taking out of a bank. Interest rate's a bit high. Okay. And again, we're divided by that same interest rate, our I value, which was 0.0104. Okay. Same idea. We need to isolate for the regular payments. So we got to figure out how much this guy's got to pay every single month in order to pay this off after 3 years. So our very first step, we got to bring over the bottom because this is divided by. When I bring it over, it becomes multiplied. 0.0104 times, I'm going to write the rest in black. 1,200 is equal to the regular payments. And we're going to simplify a little inside these brackets also. 1 plus that is 1.0104. And it's to the power of 36. Okay. We're going to calculate our side here. We get 0.0104 multiplied by 1,200, which is 12,000. What is it? Sorry? No, it's 12.48. Am I right? Can no one read that? Thank you. All right. Now what we're going to do is we're going to put 1.0104 to the power of 36. Okay? We're going to calculate this. So we get 1.04. Oh, I wrote that wrong. 1.0104 power of 36. 1.4513. Thank you, Taylor. Okay. And the last step we're going to do on the right side is we're going to simplify those brackets. So the regular payments. 1 subtracted by that. This is going to be a negative number here. Oh, thank goodness. Because that was a huge mistake if it's a negative number. We forgot something in our formula. Does anyone see where we made the mistake? Yes. Should have been a negative exponent. Okay? So this should have been a negative exponent. Because in our formula, if you look up here, it's negative n. Okay? I wrote it in wrong. Always good to look back, because that wouldn't have made sense. That would have said they're paying him for the loan in the end, which would have been very nice, but not the case. So let's erase that. We need to put that number into our equation again. 1.0104 to the power of negative 36. There we go. We get a decimal number. 1 subtract. Can you read that again to me? Beautiful. That's good. That's acceptable. So 12.48 is equal to our. Now we're going to subtract this. 1 subtract 0.689. We get 0.311. Okay. Okay. And finally, I need to isolate for R. So in order to isolate for R, we need to divide by our 0.311. On this side, they cancel out. 12.48 divided by 0.311 gives us, what is it? 40.12. Why did it what? I'll repeat that in the part. So, he needs to put in $40.12 every month in order to pay off this loan after 3 years. Okay? Let's actually figure out how much he ends up paying in the loan, so how much interest they actually charge him. So, his monthly payments we figured out his regular payments were $40.12. How many times does he make these payments over the course of 3 years if he does it monthly? That's right, which was our N. Our N value was the number of compound periods, 36. So, in order to figure out how much he actually pays, what do I do with these two numbers? You gotta multiply them. Okay? So we have our 40.12 times 36. How much did he end up paying? Total, he ends up giving back $1,444.32. But his loan, the present value of his loan was only for what? $1,200. So, they charged him interest. He ended up paying extra. 2, 3, 4, 4, 2. Over the course of 3 years, he had to pay them an extra $244.32 in order to borrow that money from them.